There we are. So, Agile and Lean software development, that's what I've been asked to talk about. I'll start with a bit of a background, the one that you already know. This is the classic way of doing software engineering. We have traditional plan-driven development. These tend to be rather long projects. I've heard of 2-year cycles in some companies, so that you start a project and you do requirements engineering and you do all sorts of analysis, design, implementation, testing, and everything, and it'll take up to 2 years from when you start the project until you're finished. Meanwhile, you have a couple of other projects, so you have a couple of projects staggered going on, so that you always have some. You're always doing some requirements engineering, but in different projects, for example. These long iterations means you don't necessarily have to follow the waterfall software development methodology, but you do follow something which is sort of like it, in the sense that you have a given order of things that you do. You do requirements engineering, and then you do analysis, and then you do design. You can, of course, go back and fix things, but the general order of things is that you follow the plan and you do these things in a certain given order. You also, with these kind of companies, you have a very clear separation of different roles. You have the management. How many of you have heard the expression that, well, the management or the marketing, they don't know what we do, they just throw us requirements and we have to do, and so that's a classic divide that you have in these plan-driven development companies. You have management on one side, you have marketing, which is something else altogether, you have the development unit, and they are a separate unit, so they don't interact that much with the others. Testing is a separate again. And if you look at requirements, that's separate people working with requirements engineering, and then once they're done, they write the requirement specification and toss that over the wall, if you will, to the developers who are then supposed to make sense of this. And once you're done, and you've done your testing, often you might outsource this to companies, for example, in Southeast Asia. You deploy, and you have a specific team that is responsible for making sure that you're able to install and start your application, if it's a big application. And then you do maintenance, which is, again, something completely different from the new development. It might be a completely different team working with the maintenance, even though maintenance might be 80 to 90% of the project's life cycle. It might be maintenance, but it's still separate teams doing that compared to the new development. And having these different separate roles and separate departments tends to influence, for example, your architecture, so that you have an architecture, you have a system that sort of mimics your organizational chart. And that's not always the best. Sometimes you have things that need to be done between the different departments or between the different architectural units then, or across several architectural units. So that's not a good idea at all times. You have these process steps, so that you do requirements, that's one process step, and you have these roles. It's sort of like the same thing as with the architecture, but you have it for the entire development process. This tend to lead to a rather conservative company, if you will. You guard your own domain. If you're a requirements engineer, you'll make sure that you're doing requirements engineering, and if it's something that doesn't look like requirements engineering, you try to push that to someone else to keep your own front yard clean. And again, that means that there's a likelihood that things simply don't get done because no one feels that they're responsible for it. This was the norm for quite a while, until we, sometime during the 90s, I'd say, we started getting this Agile movement. The main goal of this Agile movement, it started out as a grassroots movement. Rather than having this management push-down plan that everyone is supposed to adhere to, it started from the bottom up, saying that this isn't right. We're doing all these sort of things in the plan. Doesn't matter if the plan leads us off a cliff. We still need to do it because it's in the plan. So and the plan says that we should be doing ungodly hours throughout the entire week, and we don't have any time to relax or recuperate or refresh ourselves between projects or anything like that. The plan is, if you will, the god of our development organization, and we have no say against it. So as a grassroots movement, they started with the Agile community, and extreme programming came early with this. And they have a few values there that, for example, individuals and interactions is more important than processes and tools, meaning that the interaction between two developers, the interaction between a developer and a customer, and what they learn through that interaction is more important than that you have the right requirements engineering tool and you have a requirements engineering process for collecting requirements, analyzing them, negotiating them, and creating a change request based on them, which is then pushed down with the help of the tool to some lowly developer who's supposed to be doing this. Rather than having this process and tools, let the people talk to each other, let them sort things out, be more flexible in that sense. It's more important that we have software that works than that we have the most perfect design documentation or user specification, user manual, if you will. It's more important that the software does what it's supposed to do, what the customers want it to do, which isn't necessarily the same thing as what has been ordered according to requirements engineering, but that's another story. So working software is more important than comprehensive documentation. Instead of getting into these lengthy negotiations about, you said this, we delivered what we've said, so we have fulfilled our contract, and the customer is still not satisfied because that's not what they wanted. We have been misunderstood, and so on, and we need to negotiate each requirement, and we need to have contracts, and we need to have deliveries, and we need to have everything fixed in contracts. Rather than having all this, let's focus on, again, having people talking to people. What is the most important thing for you right now? And let's deliver that. Of course, there are contracts that guide this as well, but the contract specifies the format under which you are supposed to work together to develop the product, not this is the product that you're supposed to develop. These plan-driven projects, 2 years is an enormous amount of time when it comes to software development and software engineering, which means that once you actually get your product out on the market, it's roughly 2 years, possibly 3 years outdated already when you release it. Which means that, it's not quite what we need anymore. We've changed and we've reorganized and everything is, so it's completely null and void. We'll pay you, of course, because we ordered it, but we can't really use it anymore. So it's more important that you have an agile process. That's where the word comes from, really, to have a process that responds to these changes in what the customer's situation is, and adapt the product so that it still fits. It continues to fit. You start by making sure that it fits their current needs. What is the most important thing to deliver now? And it keeps fitting to the customer's requirements, because you have this interaction, you keep talking to each other, you keep adjusting the scope of the product to make sure that it fits as good as possible. And of course, this means that nothing from the old plan-driven way of working still works. You can't say that 2 months down the line we will be finished with this component, and then we can start integrating it with this other component that we're going to develop, and then 1 year from now we will be able to integrate the entire product, and then 1.5 years from now we'll start writing the user documentation of this, and so on. Of course, you can't do that, because you need to have, in order to do this change more frequently, you're able to, by minimizing the time you spend before you get feedback, you are able to figure out if you're on the right track much sooner, and then you can change much sooner as well. So the planning changes. You can't have these long cycles, you have to have shorter cycles. Changing from new requirements. So in the old plan-driven development, you had the new requirements, and that was the requirement specification from the beginning of the project. And then you had an elaborate process for dealing with change requests. Who can issue a change request? And through which channels does this change request have to go, and so on. You don't have that anymore. You instead have, again, a collaborative effort where you talk to the developers, and the developers plan together with you to make sure that this change is prioritized according to everything else that they're doing, and developed as soon as is wanted by the customers and you as a development organization. The code, well, you can't really build these heavy structures anymore. You can't spend a year and a half building just the scaffolding and then filling it out with the details later on, because the scaffolding will be wrong as well. So you'll have to write more modularized code that you can easily replace, easily change direction to. And as a consequence of that, you of course need to document code in a different way. You need to document the product in a different way. So everything changes because of these very simple and basic agile values. Just because you're responding to change much more quickly, you need to have code, planning, documentation that enables you to respond to change. It's not just saying, we'll listen to the customers and we'll respond to change. You have to have an organization, you have to have an architecture, you have to have people who are willing to and have the ability to change quickly. Scrum, which is one agile method, one that you probably have heard of, is very much that. It's just one agile method. Now we do have a whole course. Most of you are taking that in parallel to this one, I think, the Agile and Lean Software Development course. I think Torbjörn mentions all of these others, all these other agile frameworks as well there. And since he does such a good job of talking about the details of these different methods, I'm not going to go into any detail of them. Scrum, as I said, is perhaps the most commonly known. If you've heard of any agile methodology, you will probably have heard of Scrum. But I just want you to know that this is not the only one. And as I said, Torbjörn probably has already made this point for you, so there's no point in me elaborating it further. You know that there are other methods, and there's good things in all of them, and there's some things that might be improved upon in all of them. And my guess is that if you're in a position where you're able to devise the development methodology from scratch, you're going to look at all of them, or at least a couple of them, and you're going to cherry pick what's good in one method, and you're going to cherry pick what's good in another method, and you're going to merge that into something which works for you and your company. There's a benefit of sticking to the standard Scrum, for example, but you will be looking at the other methods as well, just to make sure that you have something that works as good as possible for your company. That's again being agile. Being agile is not only about being agile about the product you build, but it's also about being agile in terms of the process you use and the organization you have. Now, lean is something which is similar but not quite the same. You often bundle them together because they have a certain degree of overlap in terms of the values they want or they describe for you. Lean methodology says it right out that you're supposed to do only those things that deliver value to the customer in some form or other. And of course, agile, the ultimate goal of being agile is to do the same thing, that you're delivering value to your customers in some form or other. But whereas in agile, the focus is on that you are doing things by talking to the individuals, you're doing things by having workable software instead of documentation, all of those values. In Lean, it's more a matter of, well, go through the entire process, figure out what actually adds value, and remove everything, all the rest. Keep what adds value and remove what's waste, basically. So you have different tools in Lean manufacturing, which of course you can use when you do agile software development as well. They're not in any way competing. You can use value stream mapping, you can use Kanban boards and so on when you do Scrum development or any other agile methodology as well. That's perfectly fine. Say a few things about value stream mapping. The idea here is that you go through your entire development process, the flow of it. So when someone poses a requirement or a user story to all the different steps this user story has to go through until it's tested and delivered and accepted. And you look at what kind of value does each step add here. Now, lean manufacturing comes from, I think, Toyota in the beginning, and the focus is very much on a manufacturing industry production line. So they have all these different words. You have inventory, overproduction, and extra processing, and so on. In software engineering, of course, we don't have an inventory in that sense. What we have is work that is started but not finished. That's our inventory, if you will. So, and that happens actually more than you think, that you start implementing a feature and then it gets de-scoped. Someone decides that, no, we're not going to do this feature at this moment. We might do it in the future, or we might not do it at all. So you have a half implemented feature that you then have to put aside. That's your inventory. That might be a waste if you never pick it up again, but it's started. It's work that started. When you put in different variation points in your code, for example, you think that this might come in handy in the future. That's also, in a sense, partially performed work. You put in a variation point in the code, you put in code that you need to maintain and debug and all sorts of things, but which isn't used at the moment. That's an inventory. Overproduction, the line with a variation point between overproduction and inventory is perhaps not a very clear-cut one. A variation point that's not used, could be seen as an extra feature as well. But otherwise, it's a matter of doing things that no one has asked for. Adding features, adding functions to your code that, just in order to be complete, we need to have this function as well. No one is using it at the moment. No one has requested it, but we need to do it. For example, if I'm writing a class to do matrix multiplications and I add all the methods for doing all sorts of other matrix operations as well, even though all I'm ever after is going to be the matrix multiplication, that's a lot of extra features just because I have a class that's called matrix, so it has to do all sorts of matrix operations. Extra processing is when I do things with or around the code that doesn't add some sort of value. Passing it around, having more people looking at the code, reviewing it than is necessary for the quality of the code or the quality of some other's code. Could be examples of extra processing. Having it set on a manager's desk to sign off on before it gets to deployment, that's an extra process. What's the added value of having the manager sign off on the code? Does the manager have sufficient technological knowledge in order to actually do something useful with the code? Or is it just a matter of that they need to sign off to feel important? And that's also a handover, that you hand over the code to someone else. And handing over your work to someone else always means that you might have to go through and explain what you've done. And sometimes it's necessary. You have to hand over from different departments. You have to hand over from different parts of the system. but sometimes it's if you continue working with the code and avoid the handover, then you already have that knowledge. You don't have to explain to yourself what you're doing in order to be able to continue working with the same piece of code, and so on and so forth. I'm not going to go through all of this, or maybe I should. I mean, already I'm more than halfway through already, so why not? Motion and task switching is, again, it's not so much about the code handing owners or changing owners and doing handover of the code or the artifacts. It's about what you do in a day. If you have to switch between different types of tasks throughout the day, then you have to conceptually rethink everything or reset yourself in order to do a new task. Sometimes it's good, as I say, if there's a trade-off here, I guess, between handovers and task switching, that you want to avoid the handover, which might mean that you have to do a certain amount of task switching. Delays, well, having the manager sign off on the code might mean that you have to wait for them to actually be there so that they can sign off. That's a delay. No one is adding anything to the code. It's just sitting there waiting for someone to do the next step. Accumulating a number of change requests together in order to do a more comprehensive release of the product. So you have bug requests, you have new features and everything, and you developed in them, you sign off on them, you do quality assurance of them, and you test them and everything, but you don't release them because you want to release them as a package. That's waiting, that's a delay. And then defects are defects, bugs are bugs, no matter what, even if it's in the manufacturing industry or if it's in the software engineering, a bug is a bug. Right? So going through the process from start to finish, or actually the recommendation is to start from the end and move backwards to the process, because it's easy to look at each step as a single unit then. So going from the back of the process and up towards the start of it, where does it end? Well, we deliver something and the customer signs off on it, and going backwards until when did this request or feature or user story, whatever, enter our system. And you look at for these things. You might look for other types of wastes as well, but these are the main categories that you're looking for. And you try to figure out, is this a waste? How big a waste is it? And what can you do to reduce or remove this waste? That's one of the things that you do in lean manufacturing. That's the big thing that you do in lean manufacturing. Kanban is what you do once you have this process as streamlined as possible. Now, if you look at most agile processes, most development processes, it's, in a sense, it's a push system. You meet up in Scrum, you meet every 3 weeks, for example, and you decide for the coming 3 weeks, this is what we're going to work on. You take your backlog and you take the top prioritized items and you decide that these are the things we're going to work on, and then you push that into a project. With Kanban, it's more of a pull situation, that you have a resource, a developer, who is finished with a certain task, and then they go back to the beginning, look at what's in the backlog, and I'll pull the top item from the backlog, and I'll pull that through the entire development process. Halfway through, some other developer is finished, so they'll go back and they'll pull the next item. So it's more of individual working here, and it's more of a pull process that you, as soon as you're done, you go back and you pull the next item. You don't have this upfront planning, even if it's just every 2 weeks, you don't have this upfront planning where you decide that this is what we're focusing on now, and then push that to the developers. Each developer goes back and pull what is important at the moment. This means that you can be even faster in responding to change. So in Scrum, with a 3-week iteration, anything that happens within these 3 weeks will have to wait until the next sprint starts. You can introduce these alert sprints or whatever they're called, where you stop everything and you work on fixing a particular problem, but they should be used very sparingly. So most of the time it's a matter of that you have 3 weeks, and then after 3 weeks you take a new chunk of work and you replan and you work on that chunk of work. So every 3 weeks you have a chance of replanning or respond to the changes in planning. With Kanban, as soon as one developer is finished, they'll go back and they'll look at the backlog, and they'll take the most recent snapshot of that backlog. And then 2 hours later, the next developer is finished with whatever they are doing, and they'll go and look at the backlog, and the backlog might have changed completely. And that's okay. So they'll take the top item from this completely changed backlog. So you'll be even more responsive to changing priorities. Kanban has 3 different pillars. One is to visualize the workflow. This is what you've probably seen. You might see them in any development environment these days. You have a big whiteboard or a big board of some sort where you have this visualized flow. You have on one side, you have the backlog. These are all the items that are supposed to be done, and then you pull the items through from one column over to the next. You have a flow here from left to right. We pick items over here at the backlog, and you try to pull them over to a live deployed working software. So you've probably seen this in if you go into any development project room, and you'll see that they have some form or other of a Kanban board these days. The next item, limit work in progress. That one you don't see as often, but if you want to have proper Kanban, that's a rather important aspect. You see these red numbers here, the 2, the 3, and the 1. What they say is that in this column, you can at most have 2 items. In the development columns, you can have at most 3 items, and in the deploy column, you can have at most 1 item. What that means is that if I have, let's say I'm working on something in the development column here, and I want to deploy it. I'm finished with it, I want to deploy it. But there is already 1 item in the deployment column. That means that I can't put my item over there. The work in progress is limited to 1. What that means is that I have to go over to the deployment column, talk to the person who is in charge of whatever item is lying here, and then we'll help out. We will pool our resources to make sure that this deployment item, which is apparently holding up things, something is not working as it should. Now we are 2 people working on it. After a while, the next person will be done with something over here in the development column, and they will realize that, yeah, I can't push it to the deployment because there's already an item there. So now we're 3 people working on this problem in order to clear it out as quickly as possible. As soon as this is finished, we solve the problem, we deploy it. That person who was responsible will continue with it, move it over to the live pile or a live column, and then go back and pick a new item from the backlog. Meanwhile, I can go back and take my, if you will, my user story, and then I'll pull that over to the deployment column because now it's empty, so I can fit it there. So by limiting the work in progress, I intentionally create bottlenecks in my flow, which means that I will accumulate resources, development resources, where it's needed in order to clear the problems. And this helps the overall flow. And the last bit is to measure lead time. My velocity, or my team's velocity, is decided by how quickly I can take items from the backlog and push them or pull them over to the live pile or the deployment pile, whatever is my end pile, done or whatever. And that is, so over time, I will be pulling items through this Kanban flow, and I will develop this velocity. Might say that, well, on average, I'll do a user story in so and so many person hours, which means that when I take an item, I can already plan for that. I can say that this will be done in so and so many hours because that's my usual velocity. And when they plan the backlog and they estimate things and when you give an estimate to the customer, this will be done in so and so many days. Well, you can count from the top of the backlog. This is item number, say, 10 in the backlog, and the team's average velocity is 8 hours per user story, which means that this will be done. We will start this in 14 days, whatever. So measuring velocity, measuring lead time is an important aspect in order to be able to know how things are going in Kanban. Right, so that's what I was going to say really about Agile and Lean. And as I said, I think you probably have heard most of this from Torbjörn already, or will be hearing from him about these things. So there's no point in me going further on these items. So instead, look at the current research trends. And essentially, if you look at the research, you'll find that it fits actually into a model from another software engineering topic. So basically, you have 4 categories. And the research in Agile fits rather nicely into these 4 categories as well. You have research that looks into the business of Agile. So what kind of business decisions does it take? What kind of promises can you make to your customers? How do you get information from the customers? How do you collaborate with the customers during the process? How do you charge for what you develop, and so on? So the business leg of software development, really. The architecture. Well, everything between architecture, design, code, and all the infrastructure around it. How is this shaped? How does Agile influence what you do, and how can you change your architecture such that you facilitate being more agile, for example? And process and organization, same thing there. So development processes, any particular practices, what's the impact of using one particular practice over others? How can we be better at measuring the velocity or the lead time and so on? Those goes under the process. And then organization, for example, what's the optimal size of a Scrum team? How can we make sure that we don't miss certain aspects of the software development by making sure that we have an organization that covers for it, and so on. So basically the research falls into these 4 different categories. I did a word cloud on a workshop, which was one of those dedicated Agile workshops. Just looking at the titles, and I think of the papers that were published there, possibly the abstracts. And we see these different words. That we see process is important, and we see business, and we see testing and development, and those kind of things. A few things that we also see is large-scale agile. So agile has gone from being this small team. You have between 5, 10, possibly 15 people working as Scrum teams, and that's it. Projects maximum 6 months, nothing more than that, and probably not going to be maintaining the product for years and years and years, possibly maintenance for 1 or 2 years, and that's it. That was the start of Agile. These days we're talking about this has replaced the plan-driven. So we have projects that have been, we don't have projects, but we have products that's been developed and maintained for decades by now, developed by using Agile methods. And they have grown. So how can you take what's good in plan-driven development and then use that to scale up your Agile efforts? How can you, for example, distribute requirements from your backlog between many different Agile teams? One thing which has showed up is technical depth, because focusing on value now tends to also ignore value in the future a bit. If I can deliver something that the customer is willing to pay for now, why should I spend time also doing a good architecture for it? This was a problem before as well, but it's become more visibly a problem now. For example, by measuring lead time, if you realize that your lead time gets longer and longer for doing similar tasks that you were doing 5-10 years ago, probably is because you've accumulated quite a bit of technical debt, which means that it's more difficult to understand the code base these days, more difficult to maintain it, more difficult to understand the consequences of doing new things in it. And what can you do in terms of reducing your technical debt? Code smells is one example of things that you can do to look for accumulated technical debt. So these are the buzzwords that that research is being done in Agile. Probably more. I just took one conference as an example. One tiny little word here, safe, which is actually just large-scale Agile, one particular way of doing large-scale Agile. But you will see a lot of people talking about safe. I think more these days than 3 years ago, so it might be good for you to know that one as well. Communication is a big one, of course. Again, favoring individuals and interactions over processes and tools, that means communication. So there's a lot of research on how can we be more efficient in communicating. Right, and that tag cloud doesn't actually tell the whole story. Because what has also happened is that the research is no longer on individual practices. What is the impact of doing test-driven development? What is the impact of pair programming on code quality, developer happiness, knowledge level, and so on? Much of that research has been done. What's the difference between doing extreme programming and regular plan-driven development and so on? Most of that research has been done. The focus these days is on whole methods. So in one sense, what's the whole is, can we use extreme programming together with Scrum? Will that improve our software quality, development happiness, and so on? How does the whole method contribute to better quality, better value, not just individual practices? The teams that we focused on in the beginning, you had one Scrum team and you did experiments and evaluations of each individual Scrum team and how do they perform. These days we're looking more at how does an organization grow and learn from using Agile and Lean. We are no longer talking about these 3-week sprints or whatever. We are doing continuous deployment. That in itself leads to that we are leaning more towards perhaps wanting to do proper Kanban development where we have more of a pull. But the idea is at least that instead of just waiting till the end of 3 weeks and then pushing everything then and deploy then, we deploy as soon as we're done, even if it's, let's say we do Kanban, or sorry, let's say we do Scrum, let's say we do this plan for the coming 3 weeks and we develop something, and then we push that to deployment immediately. Once we know that this is done, the customer has agreed to it, we push that to deployment immediately. We don't wait until the end of our 3 weeks and push it then because, well, there's no point. We've tested it, it works, why wait? So continuous deployment is an important topic, and with continuous deployment, we also give ourselves tools in order to experiment with the code. Is this way of doing a certain task better than another? How much sales do we get if I'm doing, for example, an online shopping product, whatever? If I present the items that I'm trying to sell in this way, or in this other way? Which one is better? Which one do I sell more of? I can do these sort of experiments by doing continuous deployment. I'll deploy both of them to different customers, randomly selected customers, and I can measure immediately which one is better. And then as soon as I realize that, yeah, this one is better, all right, kill that one, focus on this one. And now we can do sort of same sort of experiments here at which one is better of these two, and then we can use our running platform as an experiment as well, which is much more difficult to do if we have to release everything at regular intervals. So then we have to release it, and then we have to wait for a while, and then meanwhile we should continue developing it because we don't know, and then eventually we'll learn something, and then we'll adapt our product based on that. That takes more time. These days with continuous deployment, we can get that feedback immediately. The emphasis has been changed, well, not only in terms of research, but also in very much so in industry, that the emphasis, they try to talk more about what value does this deliver. So not so much about how much will this cost in terms of development resources, what's our key performance indicators on software use or whatever, but how much value have we delivered to the customers. Many companies are trying to transition into a service or organizations instead, saying that we don't deliver software, we deliver services. And that has a whole bunch of different traps in it. I'm not sure that these companies have realized yet. For example, that if you're selling a service, you are also taking responsibility that this service is working. If you sell software, well, if it's working and or if it's not working because of some misconfiguration that the customers have done, well, it's the customers who stands the risk. If you're selling a service and it's not working, well, you're obviously responsible for the configuration of it. That's one trap that companies fall into. They think that selling services, just delivering the value, that's nice, that's just market speak, but it actually means things when you look at what you need to do. A lot of the research now is focused on taking all of these individual practices, taking all of these methods and the cherry-picked methods, if you will, what's good in all of them for one particular company, and then doing agile development sustainably, continuing to do it year after year, adding new agile teams, having them train alongside with the existing teams, having them become productive to deliver value as quickly as possible, and having them sustainably be able to deliver value year after year. That's not an easy task, actually. One of the reasons for why this is difficult is because the management now have tools that can measure more or less on an individual level each person's performance. And if you have a period where you are not performing as good as you used to, that can be seen immediately in their measures. But if you had the old plan-driven development, well, you could sort of hide away. You could have a bad day at the office, for example, or you could even hide important things that needed to be done, working on, for example, improving the software architecture, adding pieces of functionality that you know is needed, but no customer knows that they need yet. You could do that in plan-driven development. You can hide those kind of skunk works, if you will. But with Agile, because everything is so clearly defined that this is what the customer says is value right now, this is what we should be doing, we measure each person's velocity, you don't have that ability anymore to do things that are necessary unless they are planned for. Ironically, given that this started out as a counter movement to plan-driven development. And that means that a lot of things that needs to be done aren't done because no one thinks of them. And that means that it's difficult to sustainably develop with Agile for several years, more than several years. So that's one of the things that that research is working on. How can we make sure that we get these important pieces of projects done, important pieces of development done? How can we make sure that we actually have a sustainable working environment for our developers so that they have time to actually recuperate between different releases of the software and so on as well. Part of this is test automation. Test automation means that you as a developer, if you know that you have a good automated test system that will tell you if you do something that breaks the system, you have confidence in that. That means that you are more likely to actually try your change. If you don't have working test automation, what you have to do is that you have to look at whatever you want to build. You build that, and then you need to look at how does this fit in with the rest of the product, and what broke in the rest of the product because I did this. You can be more or less certain that you are breaking something if you go in and meddle with it. And if you have to do that manually, that takes time. So you're less likely to do that change in the first place because you don't know what you're going to break. With automated tests, that builds a confidence that, yeah, I'll go in and I'll fix it because the test automation will yell at me if I broke something, and then I can fix that. So that's, in a way, that's also a way of managing technical debt by avoiding it. But managing technical debt in general is a matter of all of these different shortcuts you do. For example, at the end of a project, when you have to deliver something because the customer is screaming for it right now, you do a local fix and you realize you're meaning to go back and fix it properly later on, but you never get around to it. You add something, you borrow a library that you're not really supposed to borrow because it's on the wrong license, but it solves the problem right now and you will go back and fix it later. All of those things accumulate. And they are something that you're pushing forward in front of you. And sooner or later, you need to deal with it. You need to make sure that you, those decisions that you took, because they were the best way forward at the time, they do impede you later on. For example, getting away with a local fix. Well, that means that that local fix is there and you have to maintain that. Even if you fix the proper code later on where it's supposed to be fixed, you still have this local fix here. So when you do changes, you need to change here and in your local fix, and you probably have the same local fix in many different places, which means that you end up in a maintenance nightmare. So going back and finding these places, removing them, pushing it towards the one place where the change was supposed to be done is one way of managing the technical debt, is to make sure that you remove that particular piece of technical debt. So there's a lot of research going on in terms of Agile and technical debt in order to, well, get sustainable practices. Because we are looking now at having agile products developed with agile methodologies that live for decades, and that means we can't really rely on these basement practices anymore, that we hack away until things work and then we deliver it. That doesn't work anymore because it's going to come back later and bite us. Right. I will be saying something about value, but I will be doing that after the break. So let's take a leg stretcher and come back at 1:15, if you please. I'll pause the recording now. There we are. And let's talk a bit about value. Now, a colleague of mine, Tony Gorshek, professor these days, he once did a model for requirements engineering where he talked about delivering value in the requirements engineering process, and it's generic enough so we can use it here as well. The main point that he was trying to drive here is that what delivers value in one scope doesn't necessarily mean that you're delivering value in other scopes. So what's the main goal of requirements engineering, the requirements engineering phase, for example? Well, in order to be the best possible value there is that you have all the requirements exactly right. You have all the stakeholders interviewed. You have all different stakeholder groups identified, and so on and so forth. This obviously takes an enormous amount of time, which means that the project will probably run out of time before you're finished with requirements engineering phase if you're supposed to do requirements engineering fully and properly. Same thing with the project. What's the best thing for the project? What are the success factors for a project? Well, it's to deliver on time, on budget, and on quality, right? If you have problems with, or actually that's for the entire project, but delivering on time, that's the most important thing, right, for the project. So how can we, if we realize that we are not going to deliver on time, how can we improve that? Well, we can improve it by cutting away requirements. We can remove requirements so that we deliver on time. We can throw in more resources. We can add developers so that we deliver on time still. That's obviously not good for the product, because the product will be more expensive if we add people, or it'll lack several key features because we killed them because we didn't have time to develop them, so it won't be as competitive. And what's good for the product? Well, it's to do basically everything in the domain that we are building it for example. That might cannibalize on other products in our company. If I try to do, if my goal is to do, let's say, low-end phone, whatever, and I build the best possible phone available, but I do it for half the price that our flagship phone is selling for. Well, that's not good for the company because I want to sell my flagship phones. So the product can cannibalize on each other. And then what's best for the company is not necessarily best for the society. Developing products and in places that are cheap for me might not necessarily be good because the people there are getting underpaid. Not caring too much about the environment might be good for the company if I'm able to hide it these days, but it's obviously not good for society. These days, those two are, of course, connected, so that it's not good for my company if it gets known that I'm doing things in a way that's not good for the environment as either. So there's an interplay between them as well. But the point here is that I need to look at value. Value is not just one thing. This is something that I put into the product and I deliver that to whoever wants the product. Value is delivered on many different levels. It's delivered, as I say, through the requirements phase, all the different phases in your development project, for example. It's delivered on the project as a whole, it's delivered by the product, it's delivered by the company, and it's delivered by the society. So all of these things influence the value and have values on their own. So what are the agile values then? Well, first of all, business value. Do things that the customers want. Develop what the customer needs right now, and don't do as much of the overhead around it. Don't document too much. Don't just spend time writing design documentation or whatever. Don't specify the requirements in long, overly obtuse requirements engineering documents, but focus on what's enough to understand the requirement, what's enough to build a requirement, what's enough to come to an agreement between the developers and the customers. And the rest of your effort should go into building workable software that the customers have actually requested. In Lean, we're talking about reducing costs. So we are taking an elaborate approach to actually look at what are we really doing and what is delivering value and what is actually just waste. So we can remove the waste, reduce the cost, whatever is left must be something that is actually adding value to the products or the customers and or to ourselves. We do this with value stream mapping. That's an enormously useful tool for doing this. We produce things when they are needed, but not before, just-in-time production. So if someone is requesting something, we don't do things ahead of time. We do it just as late as we can get away with, in some sense. Can we use artifacts in more than one way? For example, if we can specify our requirements in such a way that we can also use them as test cases, or vice versa, then we are getting twice the value from the same artifact. So that means that it gets cheaper to develop the artifact because we can use them in more ways. That's where you see test frameworks like Cucumber, for example, that allows you to specify requirements as a testable process. How do we assess value? That's another interesting discussion. So story points that you've probably heard of in Scrum, for example, that's the development size, if you will, of a user story. How complex is and how much is this going to cost us to develop? So a lot of people try to advocate that the backlog shouldn't be prioritized based on, well, it's not prioritized based on story points, but we should also include something called benefit points. How much do we gain if we develop this? That would, in one sense, I would say, in one sense, it would give us a nuance to what we have in the backlog. We can see how many benefit points we get from between the different items. So we might not just pick the top item on our backlog and develop that because, well, we might see something later a bit down that has higher benefit points, so we might pick that one instead. On the other hand, that means that we are adding a process to assess these benefit points. And do we really get enough value out of that in terms of delivered value, or is it just something that we do for the sake of the process? So I'm not sure. Maybe it's better to have just this backlog, which is just ordered items, nothing about benefit points there, because that's the easiest thing we can get away with. And continuous deployment and continuous experimentation, I talked about this a bit earlier. You can sum this up as saying that, well, if we don't know what the value is, let's design an experiment. Which is the better value for the customers? So let's develop a prototype. Let's develop something which is good enough so we can collect some data. People tend to start talking about big data once we get to this point, because it's since you don't know what you're looking for, you try to collect all the data that you can. And then you try to analyze and make sense of whatever data you manage to collect. So it's big data in the sense that it's unstructured and it's targeted in some sense, and it's got a relatively low information content if you look at it, because maybe 10% of everything that you can collect is actually meaningful in order to understand what's going on. But you collect everything because you don't know what those 10% are. As long as you have the storage space, as long as you have the processing space, then I suppose there's nothing wrong with it. But when people start talking about big data, they also start talking about, we need to grow, expand upon this. We need to have more data, and it's going to grow over our heads, and we need to manage that. And that's a completely different story. But these small-scale experiments, trying out different ways of doing things, and collecting, in some sense, relevant data around that, is a good way of doing continuous deployment and figuring out what is actually going to be value. Especially if you have market-driven products, you don't have this possibility to have this close interaction between the developers and the customers. You can't sit the customer down and talk to them because you don't know exactly who they are. You might know that they are a member of a particular customer group, or maybe not even that. You know that they are some random person on the internet. That's about as much as you know of them. So how can you make more sense of that? How can you see what is value to this random person? Well, you try to learn more about that person in terms of what their preferences are, where they do their shopping, how many times they post on Facebook per day, and so on, and what they post about. And then you try to get a richer picture of each of your customers so that you can see what is value to that particular customer. Right, so that about value. Let's talk a bit about lean and the flow. The idea with lean is that we try to optimize the end-to-end flow. We try to not look so much about a given process and that it should be following a certain plan or anything like that. Remember what I said about the Kanban board, that you limit work in progress in order to accumulate resources where you need in order to get as big a flow as possible through this process. And in order to do that, there are certain things that you can do in your development organization in order to help with getting this flow, or improving this flow. It's important to understand that you don't have this common startup phase anymore. You don't have this sprint planning meeting where you decide that for the coming 3 weeks we're going to do this, this, and that. You don't have this phase where everyone sits down and do planning poker or whatever. You have individuals who take an item down from the backlog, they work through that process, they work that item through the entire process, and then they deploy that. And that means that each individual is going to have more or less their own separate flow. And you need to have an infrastructure that supports this. So for example, I need to have a way to clear my machine so that I have the right tools, the right libraries, the right frameworks and everything all installed on my machine so that I can start a new iteration of this flow with a clean slate. And it should be reproducible. It should be so that the next person who comes along, they take a machine, then they get the same tools, frameworks, and versions and everything set up so that they can start working with their task, whatever that might be. Once I'm done with developing, I need to test it, and I have a common test suite, or I have access to a common test suite that I know that this is the same for everyone. And when I'm done and with the testing and I need to deploy this, I have a common way of doing that, which is the same for everyone, and I have the same rights as everyone else, and it's being deployed in the same way as everyone else's code. But I deploy mine, and someone else will deploy theirs later on, and it's completely separate from me, but it's done in the same way. What I want to have here now is a one-click setup so that I don't have to go have a checklist, for example, install this, download this package, install that, type this in a command line prompt, and then do this, run 3 laps around the block in order to get everything up and running. No, it's one script, preferably, or a button click or whatever. One way and one command to get everything cleaned up and ready for the next iteration. So that means that if I start here, I set up my environment, I develop, and I'm done, and I deploy, and then I come back, and what do? Well, I click on that button, and I get a new clean slate for the next task I'm going to do. That means that there's no junk lying around on my machine that influences what I do, so that I end up with something that works on my machine but doesn't work in the general case because I did something 3 tasks back. I did something which has changed my machine such that it works for me but not for someone else. And this is where lean and agile merges in some sense with DevOps. DevOps is a buzzword that's been coming around in the last years. It's an interesting topic, but essentially what it is that you integrate that used to be a separate part, deployment and operations. Remember one of the first slides where I had operations as a separate organizational unit? Now we want to do that together. We want to have that as part of our agile practices. And by doing that, we can also create support for this common work environment, for our infrastructure that will help us with having the same infrastructure regardless of whether we are doing local development, test development, or deployment. It's all one, and it should be managed in the same way. So one, I think, lean practice data is 5S, which is 5 things starting with the letter S. It's sort, set in order, shine, standardize, and sustain. Again, something which comes from Toyota, I guess. And these, it's nothing weird or strange. These are things that you probably do all the time, but you don't call it as such. But it's important in order to get good flow of your development. It's good to think about them. It's good to see what infrastructure you can set up to help you with it. So sorting means to remove everything that isn't necessary for the task at hand. And set in order, organize whatever is left so that you have everything neat and tidy. Scripts for building the product, shortcuts for accessing the project, whatever, buttons to deployment, code inspections, whatever you have. Shine, we tidy up and you clean your new workspace so that it works as good as possible. You find everything where you expect to find it, and so on. You standardize so that you document things so that you know how to do a thing. If you're starting a new iteration with a new work task, how do you do that? Well, there's a document that describes this is how you start with a new work task. This is the button you click on. And then you go over this ever so often, and you make sure that the documents are up to date, the build scripts are up to date, and everything is sustainable. So if I go out to my garage to work on some woodworking project, the first thing I do is I realized that I had to leave things in a hurry last time, so I have to clean my desk. That's my sort stage. So for this new project, I'm going to need a hammer. I'm going to need a chisel, and I might need some sandpaper. So I pick those out and I put them on my worktop. And then I realized that, I need to have space for my workpiece as well. So I will be putting the hammer on one side, the chisel on the other side, because I'm going to use them with both hands, and the sandpaper I'm going to put over there because I don't want it. I want it out of the way for now. So I shine. I make sure that it's clean. I sweep up whatever dust is there. So those 3 things that I do when I start a new project in my workshop. When I'm starting to cook dinner, I make sure that I have a clean desk. I do the dishes if there's anything left over. I start by looking into the cupboard to see that I have all the ingredients that I need. I have the pots and pans I need, and so on. And as I go along, if I peel some onions, I remove the onion peels. If I chop some potatoes, whatever, I remove whatever is left of that. So I keep my workplace shining as I work with my dinner. Again, these are things that you do as well in different names. The standardization of cooking dinner, I suppose I should be doing more because my kids keep asking me to do the same dish again, and I have no clue how I did it. But looking in a cookbook, for example, that's your documented work process for cooking dinner. And then going through and seeing, can I improve upon this? And this is where I usually get into trouble with my wife, because I start thinking about what's ever in the top drawer, I don't use as often as the things I use in the bottom drawer, so I'll move things around, and then she can't find things and she'll get cross with me. But that's regularly applying the standards, seeing, can I make things in a different way that will improve my flow? will improve the speed at which I can cook in that case. So let's do the same thing with the software then. Sort. Now, removing unnecessary items sounds easy. When we look at the code itself, the source code, this is a really big and hairy topic, so I'm not even going to touch it very much. What if or let's say you have features that you've developed and you only sell them to a couple of customers in the first place. So you want to have them separate from the main code base because they're only relevant for that one customer or those couple of customers. You don't want to be able to have to maintain them for everyone, even though only a couple of them are using them. So how do you know that those customers still want that piece of code? Well, you might not know that. So you might be, you have that piece of code and it's there and no one uses it anymore, especially if you had a feature that started out as doing as something that you did for one customer, you sold it to more customers, and then you realize that, yeah, I'm selling this to quite a lot of customers. Let's put this into the main code base. So now I have it in the main code base and you're maintaining it. And then those customers are gone. You're selling it to other customers. But since it's now in the main code base, you have no way of knowing if anyone uses it anymore. So removing unnecessary items is really difficult to even know that they are unnecessary if you have migrated the code into the main code base. So this is a big topic and a really interesting research topic for that matter. When it comes to your workplace, well, I, for example, work very much inside a virtual machine, which means that I can mess that virtual machine up completely. And if it's completely messed up, I can destroy that machine and I can rebuild it from scratch. So I can roll back my workplace to the steady state. And once I've developed things, if I install a number of libraries and packages, whatever, I can always create a clean virtual machine and try my product on that one to make sure that it works. So I have this one-click solution to create a new work environment for me or a new test environment for me. And nothing else that I have on my machine is influencing. I can work on several different projects, and each project is compartmentalized into one virtual machine or several virtual machines, but that are separate from each other. So sorting means that you are able to do this with your workplace. You can roll back your workplace to a steady state. How you do it, if you do it with virtual machines or if you have some other script that does it for you, that's another story. But being able to do it is important. Setting in order, again with these virtual machines, means that if I do changes inside a virtual machine, I log in and I edit things via the bash script. Those won't survive a reboot, or not necessarily survive a reboot. So what I need to do is, whatever changes I do inside a machine, if I want them to survive, I need to put them in my configuration scripts. That gives me a repeatable provisioning, so that the next time I start up this machine, the script will install those changes that I wanted installed. So that's the first item. Make sure that you have this repeatable provisioning. That sets your workplace in order. This also means that if you are a developer and someone calls you and says, "Oh, there's something wrong with the application. You need to go in and fix the bug." So you log into your production server and you fix the bug there. You know, the moment you fix things on the production server, that this will not survive a reboot. So in order to and you should never actually do that. You should never actually go in and debug or fix problems on the production servers. You should replicate the problem on your own local environment, fix the problem there, script the fix so that you can deploy it to your test suite and make sure that it actually works, not just for this particular case, but you rerun your entire test suite on it, and then you can deploy your fix to the production service. That's the cost of fixing something. Not I'll log into the production server and I'll hack away a bit for a while and that's it. That costs money, but it's not a permanent fix. Focus on the flow, so that things that you do often, create a new server, clean the database, roll back the database, or populate the database with whatever test data that you need, or the live data for that matter. If you do these things often, make sure that you have scripts for it, so that you don't have to do things manually. Shine. Well, the way I see it is that if I have my development environment, there shouldn't be any difference in my development environment and my test environment, or my deployment state. What might differ is the amount of data I have available. So of course the deployment state is the live data. The test environment might be a subset of that, say 10%, whatever, so that I don't have to deploy as many servers. And my local development might be even smaller, and I might populate it with select items that I decide. But the software stack underneath, the versions of the frameworks themselves, the development environment, compilers, interpreters, whatever, web servers, whatever I need to have, all of those things should be as close to each other as possible, so that I know that there's nothing in my local environment that is different from what's being deployed to the servers later on. And then standardize this. Document how you start new iterations, how to roll back, how to deploy, and document rules. Who may touch your production service and what can they do there? That's one of the things that's often missed. It's also one of the things why, if a developer has access to the production service, they guard that more or less with their lives, because you don't want anyone else going in there, meddling, doing things that you have no control over. So in order to avoid that and actually enable other people to actually use the production service as well, you have to have rules. This is, if you need access to the production service, well, these are the official reasons for why you could have access to the production service. And if you have access to the production service, these are the things that you're allowed to do there. And if you're able to, make sure that you restrict the users so that you can't do anything but those things. Giving a full SSH access to anyone, is in general a bad idea. One developer might need it, but not everyone. And then sustain this. Make sure that you have scripts that will help you with building and testing the product continuously, so that you know that once you're done with a piece of code, once you've built a feature and you push that upstream towards code inspections or whatever, it's going to get built, and you'll get a report on the build saying that, yeah, this worked, or this broke this part of the build, all the tests passed, or this particular test case was failed, so that you get that confidence in the development team that if I do something and I do something wrong, my development environment is going to let me know about this. This is the same thing as that the compiler will tell you when you forget a semicolon at the end of a line, but in this case it's more high level, that you're no longer able to break things in the software logically without the test script telling you that. And that means that you have a confidence as a developer that, yeah, I can do things, and if I break things logically, the development environment is going to tell me this. So I can focus on this new feature. I don't have to defensively make sure that I don't break anything of what we already have. So you create regression tests for this. You create tests as you develop. initially. You do some testing and you do exploratory testing and you find something, and then you make sure that you enshrine that into an automated regression test. Whenever there's a bug, you make sure that you write tests that explore this bug. And when you, this means that you also have the acceptance test when you fix the bug is when the tests pass. And you put those tests into your configuration management tools. And I forgot to say that about the uh, repeatable provisioning. This is also in version control. Your scripts for configuring a new machine are also in version control. They are as integral as part of your product as your software is, your source code is. So this is version controlled, your source code is version controlled, and your test suite is version controlled. So, summarize. I wonder what's left in this presentation, because there's 10 slides more, or 8. Make sure that you have a stable build and deployment environment. It can be can still be flexible, but make sure that it's stable in the sense that you have the same environment. You have an ability to create the same environment as everyone else, and that's that you just had yourself and just broke. And that means that you have a confidence that, yeah, it doesn't matter if I break this, I'm one click away from resetting it to my start state. Some risky deployments are avoided by doing this. You can, if you know that your development environment is the same as your deployment environment, that means that you should avoid these things, that it works on my machine because, well, if it works on your machine, it should work on the deployment machine because they are the same. But the bottom line for all of this is that if you look at the infrastructure, look at the tools that you use in order to support your developers, you fix the infrastructure, that means that the developers can focus on the flow, and they have support from the infrastructure to actually focus on the flow. And that's the key takeaway when you try to integrate DevOps into your lean development practices. DevOps, well, if you haven't heard that term before, the idea is that rather than having this separate team that looks at how to deploy the application, you put that in among the regular development team. You can do that in different ways. You can mix them so that everyone has the same responsibilities, or you have the teams together but with separate responsibilities. But again, the bottom line is that you make sure that your infrastructure, your setup, your install scripts or whatever, they are code, they are version controlled, and they are treated as any other piece of code. That's the most important thing. Blah, 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 blah. Again, these are agile values: communication, collaboration, and integration between developers and IT operations. So make sure that you are talking to each other rather than passing documents and process steps to each other. That's the important thing in DevOps. You're no longer a separate unit and someone gives you an application saying, hey, here's this application, make it install. You are now collaborating, you're communicating, and you are in some sense drinking your own champagne. As a developer, you get an understanding of what it takes to actually install the application. I once had the misfortune of trying to install an Oracle database. This is many years, this is 20 years ago, and they definitely had not thought about this. Throughout the entire installation process, which by the way took somewhere around 40 hours on those machines, we were asked questions, and the installation script would freeze while you answered those questions. So you would let the install run for an hour or two, and then it'll ask you a couple of questions, and then it'll run for an hour or two more, and then it'll ask you a few more questions. This is a typical example of that those that wrote the install script never had to actually install it at a customer site. in the end, we decided that 3 people in the project took shifts, guarding or watching this machine and cuddling with it and answering those questions as they arose. So we each had to do 15 hours uh, of just sitting by this machine and cuddling it in order to install things. Those are the kind of things that you try to avoid by having integrating DevOps with your development organization. Right. Blah blah. I can. Yep. So a few research ideas to finish this off. In case you're looking for things to do for your master thesis later on. First of all is some sort of open survey thing that which agile methods are actually used, or any particular practices in agile methods that are used more than others. Because I see a lot of research in agile doing the impact of doing this or the impact of doing that and so on, but does it actually have any significance in real life? Is anyone using this or not? That's harder to find out. Comparing Kanban and Scrum, as I said before, there's no real either or relationship between them. You can use both together, but which one, if you have to start with one of them, which one should you start for? Which one gives you the most bang for the buck, if you will? Global Agile, scaling up within an organization, within one site is one thing. Scaling up when you have parts of your development team across the globe might be something else that can be looked into. This idea with infrastructure as code, setting up install scripts and so on, that's nice. Version control it, yes. But what about testing of them? How do you test your install scripts? Are there any test frameworks for that? I don't think so. So that's another venue that could be researched. Different frameworks for continuous deployment, continuous experimentation. What's available? How can they be used? What's good and bad with each of them? Your automated test suite, if you do this properly, it's going to be perhaps not as big, but at least as complex as your main architect or your main product. Do you have any architecture for that? Do you have any design decisions that you've made in your test suite? Can you make design decisions? Can you make an architecture for your test suite? That would be interesting to see. And then sustainable agile. My guess is that you will come to a point where you need to add more documentation, especially when the product is old enough that people start moving out of the organization, people retire, get kids, get promoted or whatever, and you have new people coming in, and how do you communicate to them your older design decisions? Do you need to communicate your older design decisions? Are they still relevant? So if you look at an older product that's been developed with agile practices, what kind of concessions have you had to make for documentation and more the classic plan-driven approaches, just in order to make sure that it is sustainable over time? That could be interesting to look at. So that's a few ideas for future research. And a few things to read, and that's about it. So I'm going to stop the recording now.